Hi, I'm Brian Patton. I'm the VP of Engineering at Approved Networks. It really started as a closet practically. I mean, it was like I said, one rack and a couple of switches, and we kept building the library, and it got bigger and bigger and bigger. And now it's the lab facility that you see today. And we continue to grow it, beyond that. We're always upgrading, we're always cycling, bringing in the latest and greatest technology, and we'll continue to do that as the industry progresses. Our lab contains every 400 gig switch that you could pretty much imagine in the market. All the majors, Cisco, Juniper, Arista, Nokia, and that list is ever growing. We try to keep the most current and most common switches so that we can cover every coding possibility that there is. In addition to the 400 gig switches on our current lab, we also have our 800 gigs already in the plans. The 400 gig switches that we have now were in our hands before they were even released in the market, so we can stay on the bleeding edge when it comes to technology. A lot of the industry's testing procedures are based on function. That's only half the battle when it comes to transceivers. The compatibility is really the most important part for a lot of these switches. A generic standard module in an MSA configuration doesn't function in all switches. You have to have specific OEM coding. And again, we go back to your Cisco, your Junipers, your Aristas, your Nokias. All of those OEMs matter, and they all have different pieces that they require for their optics to work. Because we have the diversity in the switch base, we can test those products in their intended environment, and not only for the individual specifications for the module, but for distance, for those individual compatibilities, for the nuance that comes with a coded environment. And being able to test that in the environment that it's going to be in the field gives us a leg up on anybody. When we first built the lab here at Approved Networks years ago, the industry was at a 1 gig space, and that was really the cap. That was the top of the line. We've built that since that date from 100 gig to 400 gig. The test gear that we use is from a number of the top providers in the industry, Veex, Xena Networks, Viavi, Exfo, Multilane. These are all specification and functional tests in addition to our coding tests that happen in multiple phases during our production process. They happen during our initial qualification of products, they happen during our quality control process, and they happen during production. We're at 400 gig today. We've already ordered our 800 gig gear, and we're currently working on our 1.2 terabit planned for next quarter. So we try to stay far ahead of what the industry is and far ahead of even what the switches that are released to the market is. The optical pieces that we code and test are ready before a switch ever hits the market. Unlike an OEM optic that is purchased through distribution, it comes from the manufacturer and goes straight to the distribution and sits on a shelf. Our products have multiple test points. Even our products in distribution, as they come through our facility, are tested during the qualification phases. They have an initial QC upon receipt from our contract manufacturers. Then they're tested again after the coding process and tested in their intended environment is yet another test. Those combination of tests give us less than a 1% failure rate across the board in every product that we sell. Our lab staff and our quality control staff have been trained in not only the operations of the switches that we test these products in, but in all that test gear as well. Our manufacturing process and our manufacturing orders, all of those tested products are tied to that manufacturing order, which is then tied to a sales order, which is what the customer sees. So at any point in the future, if there were some sort of issue or troubleshooting issue that we wanted to dig deeper into, all of the test results from that manufacturing order are stored in perpetuity in our systems so that we can at any point go back and compare what we saw in our lab to what the customer is seeing in their environment. The training procedures that our staff has gone through has all been designed by me. So I know that they can work, before they ever set foot in the lab and are allowed to touch our parts, I want to have 100% confidence in everything they do. I want them to be able to work autonomously. I want them to think. I want them to try new things. There's nothing that they can do during our design phases or during our experimentation process before it becomes a full product that can get broken that we can't fix. So I empower them to really push the envelope of not only our process, but the products as well. We want to push them to the edges of what the part can really do in a switch and see how far we can take things. And that's allowed us, both with myself and the staff, has allowed us to really design products that don't exist a lot of times, or to put them into environments that they really weren't intended to get a solution that works that the standard OEM can't touch. My crew, my staff, my scurvy band of pirates, there's nobody better in this industry than the guys that you'll run into back there. And I have absolute faith in every one of them. And that, boys and girls, is how it works.